Okay, so now we're going to continue with this process. First, we're going to give it its proper name. What we just found is a percentile. And you probably have heard the word percentile when you get your standardized exam scores back. You scored in the 70th percentile or whatever you may have scored. First, what does that mean? The percentile. So I've just picked a number at random. I've said we want the 19th percentile. And by the way, the abbreviation for percentile is %ILE. You write this about 1 or 2 times, you get tired of writing it. And so we will use this abbreviation for percentile. So percentile means this. The 19th percentile means that 19% of the population is less than this score. We want to find the score that has this property. We want 19% of the population to be less than the score we're discussing. Percentile is always less than. Percentile is always to the left. In terms of the normal curve, here's what that means. In the previous problem, we found a value that had this was essentially, it was 0.1003. This is approximately 10%. We essentially found the 10th percentile. The 19th percentile means this. First off, change percent to a decimal. 19% translates to 0.19, and since our table always uses 4 decimal places, so you will do this translation every time. 19 percentile means 0.19, which means 0.1900. Suppose we were finding the 30th percentile. That corresponds to 30%, which translates to, move the decimal, 0.30, add 2 extra decimals, that corresponds to 0.3000. Similarly, suppose we wanted the 80th percentile. That corresponds to 0.80. I'm sorry, that corresponds to 80%, which corresponds to 0.80, which corresponds to 0.8000. So you do this translation every time. So we want the 19th percentile. What does that mean? That means that this proportion goes on the arrow, because the arrow is always to the left, percentile is always to the left. It's a perfect match. So 19%, 0.19, 0.1900, that number goes on the arrow. Later on, suppose we're doing the 30th percentile, 30%, 0.30, 0.3000, that number would go on the arrow. This number would go on the arrow. So the percentile determines the value that's on the arrow. Our task now is to work down to find this number. Suppose we're given the same as we had before. So mean is 24, standard deviation is 2.5. Our task is to find this number. We do precisely the same work as we've done before. We need to find 0.1900 in the body of the table, and then we need to look out to find the value it would have come from. Now here is the issue we have. I'm going to put the normal table here. We need to find 0.1900 in the body of the table. My recommendation is this. Look vertically until you find 0.19 or something approximate. I found 0.1977. So look vertically until you find the number approximately, and now start searching horizontally to find the number in question. I have 0.1977. I have 0.1949, that's getting closer, 0.1922, that's getting closer, and then I have 0.1894. So I want to emphasize those values. So I have 0.1922, 0.1894. Let me slide this in here so we can see a little better. Our value that we want falls between 0.1922 and 0.1894. That's always the procedure. Find the two numbers between which our number falls. Find the two numbers between which 0.1900 falls between 0.1922 and 0.1894. All right? So, you look at the z-scores to which that corresponds. See if I can get them on my screen here. And so, if we were to use the 0.1922, that would correspond to a z-score of 0.087, 0.08, negative 0.087. If we use 0.1922, negative 0.087. If we were to use the 0.1894, we would use the negative 0.8. I'm saying this wrong. Negative 0.88. So the question is, which of these two do we use? The answer is use the closer. There's a great big what if sitting here. We'll kick that down the road for now. But for now, choose the closer of the two. Well, which one of these is closer? This is off from 1922. That's off by 22. This is off from 1894. This is only off by 6. Do we see, strictly speaking, it's off by 0.0022. This is off by 0.0006. But just think of it in terms of the numbers without the decimals. 1900 is off here by 22. 1900 here is off by 6. This is the closer of the two. You do not always choose the larger. You do not always choose the smaller. You choose the closer. So we're going to choose the 0.894. So find the two values between which this falls. 0.1894. This is off by 6. This is off by 22. This is the value we're going to pick. And now you look outward to see the z-score whence this came. Negative 0.88. Negative 0.88. So the z-score we want is negative 0.88 is the z-score. All right, so now let's go back into our original work. Oh, goodness, where's my work? Making a hash of this. There we are. All right, so we have 0.1900, and we have, let's go ahead and score this up here. So we had 0.1900, which fell between 0.1922, and the other was 0.1894. This is the closer. The z-score that came from was negative 0.88. That is the z-score. Negative 0.88. So we found the z-score. We're working our way back down the hill. And now the last piece is we need to find the x-score to which that corresponds. And so now, find x. So we have z equals x minus mu over sigma. Plug in the values we know. Negative 0.88 is equal to, don't know yet, minus 24, 2.5. Cross multiply, set equal, and solve. I want to move this over here. So cross multiply, x minus 24 is equal to, multiply this way, 0.88 times 2.5. And calculator that. So negative 0.88 times 2.5 is negative 2.2. Add the 24 across, right? Add the 24 across. And so add 24, that gives us 21.8. So 21.8 is the value here. 21.8 is the 19th percentile. It is the score that has 19% of the population to its left.